So welcome everyone once again. My name is Carla Gonzalez. I'm the manager of undergraduate advising for the School of Engineering, and for the purpose of today, I will be the moderator. So I'll be asking the questions along the way to make sure that we kind of continue onward and have an open dialogue. Should you have any questions for any of the panelists, please feel free to use that Q&A button and ask your question. We'll make sure to get it in and respond it to as soon as possible. Couple of things so that you are aware, again, the Q&A button, and also this session will be recorded and will be posted on the Engineering Advising website along with all the other events that we will be hosting. Please feel free to ask any questions along the way. So let's go ahead and jump in. I'm going to ask all the panelists this question, and starting with Professor Kurtz. Tell us about yourself. Why UC Merced? What led you to choose UC Merced?
Yes, so I'm Sarah Kurtz, and I've been here at UC Merced just since 2017, actually not yet quite 3 years. And it's actually a bit of a surprise that I ended up here at UC Merced. When I graduated from, when I got my PhD in 1985, I took a postdoc at what was at that time the Solar Energy Research Institute. And it was actually my plan to get an academic position after that. But it turned out that I ended up staying at the lab for more than 30 years and came here in 2017 instead of in 1987. And so I sometimes tell people that I'm just like 30 years behind schedule. But the reason why I came to UC Merced was that one day Roland Winston, who's a professor here, called me up and said, Sarah, we just posted a position. I'd like you to apply for it. And I hadn't been looking at all, but I started thinking about it. California is a great place. It's leading the world in a lot of things, like the energy transition is the one that I'm interested in. It leads the world in some other things too. And UC Merced is a really interesting place because it's growing. And it's really fun to be part of a new school that's growing and defining itself and finding directions for lots of people. So I'm really pleased to be here, even though it was kind of part of my master plan back in 1985, but actually, I hadn't, in 1985, UC Merced didn't exist. So maybe that's why I didn't make the move then. But anyway, Zach?
All right, hi everybody. My name is Zachary. I am a fifth year material science and engineering student here. I actually came to the campus in 2015, and I was originally interested in attending because of the nanotechnology program. When I was searching for campuses and looking for a major that I thought I could call home, material science popped out to me, and I had a cousin who had come here a few years while back, and she had nothing but glowing things to say about the campus. It was very new, very small, and the coursework and the faculty-student sort of interactions were very intimate. So I've pretty much been with material science ever since, and specifically trending towards the nanotechnology emphasis, which I now have. And that's an amazing thing that the campus offers, which is that particular emphasis for material science majors. So that's why I'm here. Sydney?
Hi everyone, I'm Cindy. I'm also a fifth year material scientist, and I chose UC Merced because of all the opportunities. I originally wasn't material science, and I was undeclared engineering. I really wanted to come here because I had heard that it's so much easier to do research here versus impacted university like UC Berkeley or UC Davis. So, and that really benefited me. I've done research on campus, and that's been one of my favorite experiences being here.
Great, thanks. Another question for you guys. Could you tell us about the major or the department, some information?
Well, I might say that when I was an undergraduate, and in fact, when I was a graduate student, there really wasn't a material science department. So I never considered majoring in material science. I majored in chemistry and in physics when I was an undergraduate, and in chemical physics when I was a graduate student. But the thing I really love about material science is it brings together a lot of different disciplines, and it puts them together in things that are useful. So if you look around you, everywhere in your room, whether it's the computer, whether it's the light bulb, with the house around you, all of these are materials, and we put them together using a good understanding of chemistry and physics. And so if you'd like to be able to help make the things around you be more effective and efficient, lower cost, longer life, all that sort of thing, materials science is a good degree for you.
I could not agree more with what Professor Kurtz said. The material science department is very interdisciplinary, and although it's small, its best attribute is its size, I believe, because as Sarah Kurtz was saying, there are many different things that you can do with material science to blend all of these different fields together. So for me, the major in the department kind of represents the best of chemistry and physics and engineering all in one. So if that's what you're interested in, this is probably the best place for that.
Kind of going off of that, that's one of my favorite parts as well as about material science is how it just weaves every single subject into one. And I really liked physics and I really liked chemistry, and I was like, oh man, which one do I want? And I really like math. And then this just combines everything so perfectly. So this was just the best major that I could think of. I was so excited when I heard about it and what you can do with it.
Fantastic, thank you. Another general question for you guys. What are some good academic behaviors to be successful in engineering in general, or in particular in material science and engineering?
Well, a key thing is communication. So to understand what's been asked for you to learn and to actually figure out if you've learned it. And sometimes it turns out that you get stuck. Going and asking for help, first asking for help from other students. And I think that that's one thing you find that the MSE department, partly because it's so small, it can be actually really close-knit and the students can be well connected to help each other. And then if the students can't figure it out together, then going to the professor. And what you find is, again, because it's small, the professor has some time usually to spend with you to figure out what's going on. To make sure that you're not just looking at what was it that was asked, but do you understand what it was you did? And if you don't understand it, to go and ask some questions.
Yes, again, I will have to echo what Sarah Kurtz said, because the communication of scientific information is one of the most emphasized things in this major. And a good way to kind of shortcut a lot of your learning is to find peers who are also working on the problems that you're working on. So when you're all working at the same sort of an issue together, it's much, much quicker to come up with a solution, and everybody can kind of fill in the gaps of everybody else's learning. So I think that is probably the single most significant takeaway that I can give any sort of second year student, is to find a similar community of students who you can work with on these sorts of problems, so that you can really speed up each other's learning. And that I find has been very helpful for my academic career.
I think my piece of advice would be reviewing the notes beforehand, because I actually learned more when I had a little bit of background knowledge and then I went to lecture and I was able to connect those dots that I didn't see how they were flowing. So I think doing that, and then also afterwards reviewing my notes, it just helped me like keep those connections in place, so that when the midterm came around or the final came around, I had a better sense of what was going on versus having to go back to chapter 1 and read the entire textbook.
Great, thank you guys. I do have a question about what is MSE? What is material science and engineering? And Sarah, you kind of talked about it a little bit and said that it was a combination of things. Can you expand on that?
Yeah, so you need to understand a little bit of everything. And engineering, one of the questions people sometimes ask that I felt like I never really learned when I was at that age. So what's the difference between science and engineering? We often talk about science and engineering. And what's the difference between them? And often the people working on science will be looking at understanding what are the laws of nature? What are the fundamentals? How do we understand how things work? But then engineering is often making things work so that we can do something useful with them. And one of the nice things about material science, and it's material science and engineering, is that you get both the science, you learn how things work. So you take the chemistry course, you take the physics course, you also have a calculus course, so you understand how to do the math, because if you don't understand how to do math, and a really important thing is to know how to do units, because it turns out units, if you say somebody is too tall and you don't say it's 2 meters and they think it's 2 feet, that's a very different thing. So knowing exactly what the units are is really important. So you need to know chemistry, physics, math, sometimes even a little biology. So you need a little bit of everything, and then you put it together to solve problems, to do things that are useful. And so the science part is understanding how things work, and the engineering part is actually making them work. And you get a wide variety of courses. So if you like to have a wide variety of things, MSE is a very interesting degree. And also, I think as the world progresses, what people are finding is that a lot of the simple problems have been solved. And now to solve the more difficult problems, we need people who understand different aspects of things. And so multidisciplinary teams where everybody brings together a different perspective, and then we can use a little expertise from this person, from that person, from another person to come up with the final product. A material scientist is a crucial part of almost every team you look at in terms of being able to put a new product out there.
Oh, what a wonderful explanation. Thank you so much for that. Another general question for you guys are, what are some resources that students should utilize at UC Merced, or clubs or organizations that they should participate in?
How about I let Zachary take that one since I took the last one?
Sure. So I'm the president of MRS, which is the Materials Research Society on campus. And one of the things that we aspire to do is to keep, especially in times like these, the material science students interested and inspired by interesting and unique research that's happening in different industrial sort of endeavors that are happening around us in the world. And so I would say that clubs and organizations would make a fantastic place for any sort of undergraduate to start. And on top of that, I think in your third and fourth year, but preferably sooner, I think going for career resources, so the Career Center or academic advising, but especially the Career Center would be very useful. The Career Center is what helps me get many of my first internships and jobs, and so that is a fantastic resource, I think, for any student.
Adding on to that, I think some of the tutoring that's offered on campus, like the Math Center, is really, really helpful. And honestly, office hours, there's so much help, especially since a lot of students don't go to them all the time. It's really helpful to have that one-on-one with your professor and get answers to questions that you wouldn't usually do during lecture.
Great, thank you guys. Professor Kurtz, what are your research interests?
So my primary research interest right now is to change the energy system we use so that it's one that is both clean and sustainable. And I say to my students, they'll probably tell you I say this like every week, the beautiful thing about renewable energy is the more you use it, the cheaper it gets, which paves the pathway to prosperity for the whole world. So what we're seeing is that we're in a time of a revolution of the energy system, and people aren't aware of it, but being able to see how it can completely transform. Within the material science area, we have here researchers that are working on fuel cells, on batteries, on supercapacitors, all kinds of different materials that can be used within that. And I have a group working on modeling about how we will put in storage. For those of you who are here in California during August, you know that there were these rolling blackouts. You probably heard about them turning off the electricity because we didn't have enough electricity to run the state. And it's a question, if you rely on solar and wind electricity, what do you do when the sun sets on a day when the wind isn't blowing? Do you have enough storage to meet all of your needs? And if it's a really, really hot day, that may be a big demand. So there are lots and lots of different things that come in. I'm really blessed to be part of a research community at a time when things are progressing so fast.
Thank you so much for that. Zach, do you participate in any research projects?
Yeah, actually, I believe Sarah Kurtz was one of the first professors I reached out to. I think I had just finished her electron microscopy class, and I was blown away that they would ever let undergraduates touch $1 million machine. I couldn't believe it. So I thought, okay, if this is what research is like, I surely need to do some more. So I was fortunate enough to have a research opportunity at UC Santa Cruz studying electrocatalysts for the ammonia industry. And this last summer, I was fortunate enough to work in a computational materials lab with Professor Beth Naudenick. And also during the summer, I worked with Lawrence Livermore Laboratories on the data science challenge, which for their particular purposes, they wanted to know if you could screen chemicals to tell if they were explosive or not, just with their structure alone. And so this was a really interesting research topic for national security purposes and these sorts of things. So there are many research opportunities. I can talk about them later if we have time, but lots of good ones.
How about yourself, Sydney? Are you part of any research projects or any clubs or organizations on campus or outside?
I'm actually part of the MRS club as well, but I actually did research this summer with Professor Anderson Aguilas, and I really learned a lot. I was working on designing a contact angle goniometer. So it basically measures the contact angle for different surfaces. And in his research, we were doing trying to measure the interfacial forces between hip implants and epithelial tissues. So that was something really cool because the previous semester he was my professor for material characterization, and I got to work with the SEM and AFM and different electron microscopy things and the goniometer. So it was really cool to apply what I just learned into a research team.
Great, thank you. Professor Kurtz, how do students get involved in research?
Well, there are several ways. I think that a lot of students tend to approach a professor that they've had in a classroom, and they get to know that professor a little bit. And so they think, oh, you know, I could work with this person. But you can also go onto the websites. Every professor has a website that describes their research. And then you can identify one who has research going on that you're interested in. But an even better way is to talk to the upperclassmen who have been doing research in a lab and to find out which labs are a good choice. And you'll find out, it's good to find a professor who you both enjoy the research they're doing, but also get along with well personally. And not every professor has the bandwidth to take on as many undergraduates as ask. But I think you'll find that most of the professors do try to accommodate undergraduates who want to work on their groups to the extent that they're able to. And so they're usually pleased to have you approach them. So ask around. It's networking usually that finds the right place for you.
Thank you so much for that. Zach, would MSc students benefit from doing research or internships or both?
I think students would benefit probably most from doing both, because when I started out doing research, I didn't immediately find my perfect research match. It wasn't quite what I was interested in. Electrochemistry and catalysts were very interesting at the time. However, there's another subset of material science, which is not so focused at the lab bench, which is centered on computational material science, which is computer-assisted work. And I have found personally in my experiences that that is a better fit for me. So I would just recommend that students search around to find what it is that they're interested in. And most importantly, that they just inspire the passion for materials at whatever cost, and they just try and preserve that passion. And that'll take them as far as they need to go. But yeah, certainly searching around for any opportunity, find what fits best for you.
Wonderful, thank you. Sydney, do you have any courses that you've struggled with in the past? And if so, how were you able to successfully pass those courses?
I think my harder courses, I really knew that they were going to be hard, so I went ahead and just allotted extra time for them and just made an extra effort for those courses and knew that they were going to be challenging. So I would go to office hours, I would study, I'd read research articles, and just ask for like extra resources if there weren't any.
Thank you so much. Professor Kurtz, a question for you. What kind of careers can students go into by pursuing a degree in material science and engineering?
There are many different careers. So the first thing we often ask about is what type of organization. Do students want to go into an academic position where they're teaching? They want to go into an industrial position where they're helping with making products, or do they want to go into a national lab where they're doing research on the behalf of the community? And each of those has a wide range of things. Research is a really special thing that it's really fun because you get to go and do new things. And if I teach the same class over and over and over again, when I was in graduate school, I was a teaching assistant for one class for like 4 years in a row. And it was like, I told them and I've told them and I've told them, haven't they gotten it yet? You know, and after a while I run out of patience. So the beautiful thing for the research is that you're always doing something new. You're always pushing to do something new, but the competition is really tough. And if you're not really passionate about it and ready to compete with the top people in the world, research might not be the best thing. Going into manufacturing is a really interesting thing because we need things that work. And you've all been frustrated, I think, to see that, like, if you buy something and then it breaks right away. So I spent about 10 years of my time at the National Renewable Energy Laboratory looking at reliability issues. How do you make sure that the product that's getting sold is something that's really going to work? You know, it's easy to make one that works once, but can you make 1 million of those and have every million one of them work well and not break? So those are things that if you can work on a manufacturing line, it turns out nowadays manufacturing lines are the best places to do research. Teaching is a wonderful career. You can influence the lives of so many students coming through, and you can actually nowadays the teaching is progressing because as the knowledge that's available in the world changes, that both the techniques for teaching and the material that's taught is changing with time. And if you like working with people or like working with students, then teaching is a really good thing because you can have all that time to support the students and help them. So that's just a small fraction of the jobs. I could talk a long time about the difference between a national lab and a university and an industry, but probably we should move on unless someone has a question.
Well, here is another question, but this question is for the students, Zach and Sydney. What are your career plans after graduation?
Well, for me, I plan on trying to continue with my education. I am currently in the process of applying for several PhD programs, so we'll see how that ends up. But yeah, that's where I stand. I really enjoyed research, and so I plan on trying to continue my learning.
I actually want to go into industry, so I want to go and do research and development for new materials or quality control or reliability and failure analysis. So I really want to apply that materials characterization in there.
Wonderful, thanks, guys. A general question for everyone: would minoring be good if you're an MSE major? If so, what minor would be good? What sort of emphasis would you say?
So I think if you can fit it into your schedule, nowadays, the more multidisciplinary of an education you can get, the better. So if you can combine any kind of minor, whether it's chemistry or physics or math or whatever, any of those can be very useful. Just keep in mind that the world needs multidisciplinary people, and to the extent that you can find two different areas to combine together, that will make you more valuable.
Yeah, I would agree exactly along the same lines as Professor Kurtz. I think a chemistry minor, a mathematics minor, a physics minor would be very, very valuable for making you look more desirable after the 4-year university experience.
I also think chemistry would be a really good one, and biology. Let's say you want to go into like biological materials and work with that. It'd be really helpful to have a biological background.
Thank you so much. Sydney, a question for you. Why did you choose to go into industry instead of graduate school? Is there something that students should consider in when making this choice? And I'll open it up to the rest afterwards.
I think personally, I wanted that variety that material science can give you, so I get to look at different career paths and work on medical products for 5 years, and then work on engines for 10 years. It's just such a variety that I can get there. And I also think, for me personally, financially, I want to be able to pay off my loans first and then pursue grad school if I choose to do so. That's another reason.
In my case, I was looking at grad school more for applicability towards the research interests I wanted to work towards. So for some of the computational material science, you need an understanding of quantum mechanics and the principles that are happening at the atomic level. And so unfortunately, going directly into industry for that is a little bit more difficult.
So I think it's really important that students think about what kind of career they'd like, what kind of a job they'd like in the end, and that then they get the training that's useful for that. And a PhD can really open doors. You can get jobs that you can't get if you don't have a PhD. But there are other times when a PhD is a liability. A master's nowadays is becoming more consistently valued, but it can be, if you're not exactly sure what field you want to go into, it can be really useful to have a couple of years experience working in industry or working someplace before going into graduate school, because then you'll be a lot clearer about what you want to do and why you're going to graduate school. So it all depends. If you're very clear on what direction you want to go and a PhD is a prerequisite for the career direction you want, you should go straight on into graduate school. Go straight on through and you'll find it's really fun and exciting. But if you're one who's kind of questioning, why am I doing this? I remember when I was an undergraduate, I figured I spent 50% of my time convincing myself I really wanted to learn it. Then once I decided I really wanted to do that problem set or whatever, I could just sit down and do it. But it was like 50% of the time convincing myself that I wanted to do that. Then once I decided, like, I ended up working on solar cells straight in graduate school and straight out, creating a new technology with solar cells. Some of the solar cells that we developed when I was at the lab ended up flying on missions to Mars. So they power the Mars rovers. And how cool is that? You know, once you get an idea, this is what I want to do with my life, and it's something that requires a PhD, then it makes it really clear, okay, this is something I want to do. But if you're like, oh, I'm not sure what I want to do, then maybe taking a couple of years to spend time in industry, you find out better what exactly it is.
Wonderful. Thank you so much. This question is for Zach and Sydney. How do you study, and what has contributed to your success as a UC Merced student? What are some tips you might give students who are entering into their second year to help them study better?
So I think my best piece of advice for students who are looking for good study tips would be to put a lot of emphasis into homeworks, because the work adds up quickly in material science, especially in the more difficult classes like thermodynamics and kinetics and these sorts of classes. So I would say give all of your work an honest effort and try and understand fully the assignments that you're given and the questions that you're asked.
And I think for me, having really good notes and really good note taking and getting that skill down, because I often have to refer back to my engineering thermodynamics and have to look through my notes, and I want to make sure that I can go and reference certain equations or certain theories behind what I need.
It was a long time ago, but I remember when I was taking classes, I would scribble notes as fast as I could during the lectures, and then I would take an hour and I would copy the notes over very carefully, and then I'd make sure I understood every point, and that really made a big difference.
Wonderful, thank you. Professor Kurtz, a question for you. Any advice to students that might not have the GPA, but are still considering going into graduate school?
Yes, so the GPA is one indicator of performance, but another one is just how well you can get things done. If you don't have a strong GPA, it would be really useful to get into graduate school to have a very strong set of letters of recommendation from some professors. So it is really critical to take the opportunity to do some research in a professor's lab and then have that professor know you well enough to be able to write a strong letter of recommendation. If you can do that, even if your GPA isn't that great, you may be able to get in. When I was in graduate school, I did not do at all well in classes. I was like at the bottom of class in terms of the coursework. Some of the other students had a much better preparation there, but I had had a lot of experience in the lab and was able to, I knew a lot of lab techniques. And so there needs to be a balance there, and both are important. In the end, employers want people who can get the job done, and being able to sit and take a test is actually not something that you do very often once you finish school. Usually you may have to write a lot of papers, you have to write a lot of documents and get things done, but being able to sit in a room for an hour or two and answer a bunch of questions while the clock is ticking, which is something that some students kind of freak out and just get anxious about, it's actually not something that you do in the real world. So the GPA is not necessarily the indicator, but in order to get accepted, you have to have something about your application that stands out. And so if it's not the GPA, you need to find some other way to make your application shine.
Wonderful, thank you. Sydney, a question for you, and I'll ask Zach the same question. Who did you seek advice from when you started planning your courses or even planning your career? Who did you talk to?
When I actually chose my major and well, MSE, I had talked to friends in my engineering courses, and there's only a handful of material scientists. So when I heard about their major and what they do, that's when I went into it. But I think my academic advisor really helped me plan my courses accordingly and be able to graduate on time.
Yeah, I have also probably sent maybe a dozen emails to Carla and Luz, who are on this panel, specifically to address this question. How do I organize my schedule? How do I ensure I'm meeting the requirements of my degree path? When are these sorts of courses going to be available? I think maybe more so for MSE than for many other majors, it's very important to keep a close relationship with your advisors so that you can ensure you're completing everything on time.
How about when discussing your future goals? Who did you speak to then?
I think that would be professors and basically just professors.
Yeah, I think for some of the members of MRS, we were fortunate enough to be kind of connected with some of the graduating class. So I've actually been asking some of the previously graduated alum what sorts of things that they're doing with their careers, whether they've gone into industry or research. So potentially just keeping in contact with your peers even after graduation can pay off as well.
Wonderful, thank you. A general question. Do you guys have a mentor? How do you find a mentor?
I think a mentor is someone who finds you. I think somehow there is, it doesn't quite work the other way around. When you force it, it just doesn't quite work. But for me and my research labs, many of my mentors have been my PhD students, my PhD candidates, who have been able to caution me against things I should look out for. And I've developed a very close relationship with the PhD students of the labs that I've worked at. So that might be a shortcut, but ultimately that's a very difficult question to answer.
Yeah, I think the best way to find one is just to know a bunch of people and make as many connections as you can until one fits.
Wonderful, thank you. So we're coming down to the last couple of questions. So if you have any other questions that you would like to have responded to by the panel, please feel free to use that question and answer button. Professor Kurtz, what other research topics are being are available at UC Merced in the Material Science and Engineering department?
Well, a really fun one is under Professor Wang, Jessica Wang, is working on adaptive materials. These are materials that if, for example, you hit them, they get hard. Some of you may have sometime played with a slurry of cornstarch, and you can find that if you don't touch it, it just turns into a liquid and flows. But if you hit it, it turns hard. And so she's making things that, like if you wanted to make a bulletproof vest, wouldn't you love to have a material that it's flexible, it's comfortable to wear like regular clothing, but if a bullet hits it, it turns hard really fast. And it turns out that there are such materials, but designing them and understanding how they work and how to make them better is pretty complicated. And so her lab is dedicated to working on that. Now, you have Ashley Martini is working on tribological coatings, which are hard. So if you look at maybe the disk drive in your computer and it's spinning, it has a little needle that runs across it, and eventually it will wear it out. So you want to make it so that the material is really hard so that it can be scratched many times before it actually looks scratched. So there is then the MSE program, which is a partnership with NASA. Dr. Liu is the director of that, but there are many different projects developing materials that can be used on flights that NASA may be planning. We could go through a long list. The MBSE, the Materials and Biomaterials Science and Engineering graduate faculty have now more than 30 faculty. And so it's actually a pretty long list, but they're all on the website. And if you have questions about any of them, you can contact me.
Wonderful, thank you so much. And our final question for today for all of our panelists is, what piece of advice would you give to a second-year student to make them successful at UC Merced and beyond?
So my advice would be to be curious and to ask a lot of questions. Think about, why is it that way? And in today's world, it's really, really, really important to think about what you hear. We hear so much that's contradictory. Depending upon which news source you go to, you'll hear one version of a story or a completely different version. And sometimes you read two different versions of the same event and you go like, how could that be that's so different? So be curious about what is the reality and ask questions and be ready to analyze the answers so that you can identify what the fundamental science tells us about how we can progress and solve the problems of the world.
I don't know how I can follow that, but that is essentially what I would say as well. Maintain some curiosity, try to read different materials related articles, which aren't quite exactly aligned with your field, but keep you passionate about the topic. And yeah, just maintain some sort of a critical lens through the world. And the materials, I think, is one of the most fascinating fields that there is. So I'm sure it's essentially limitless, that you could probably go through hours and hours and hours and hours of content. You could probably never even scratch the surface of material science.
I think the only last thing I would say is try to connect the dots with your engineering fundamentals and basic chemistry and physics courses to and see how they relate to one another and see how much you can learn when you add them together. So I think that's really crucial.
Thank you, everybody, so much. Thank you, everyone, for logging in and attending. Thank you to our panelists for participating. Should you have any questions or follow-ups, please feel free to either email them directly. Zach has put in his contact information on the chat, and he, again, is part of the Materials Research Society, MRS. Feel free to look them up and chat with them there. We thank Professor Kurtz for her time. Thank you, everyone. Feel free to visit us during any of our other events that are happening this week. Have a great day.